Alrighty, in chapter 10, we're going to start some statistics. We're going to start off with what I think is not going to be too difficult, which are some frequency distributions. So a frequency is just going to ask us how many times something comes up. So I've got some data down here below, and I've given us the intervals already, and we just have to fill in the frequency. So I'm going to come up here to the top, and I'm going to figure out how many numbers are between 70 and 79. And how many numbers are between 80 and 89. I use a tally system for this. So like 85 would be in this second interval. 110 would be down here at the bottom. And I just put a tally mark or a tick mark for everywhere, each one of these numbers. 98, 120, and you should have one for each mark. You don't want to skip any. And we're just going to do this for each one of the numbers. So not incredibly taxing. All right, so there is our frequency distribution. Now I'm going to use this to make a histogram, and you've got some pictures of histograms down below. So they're these graphs that use rectangles or bars. This is not a bar graph. A bar graph is usually used for categorical data or qualitative data, like maybe what your favorite ice cream flavor is. And these histograms are going to be used for numerical or quantitative data. We also, one other difference is the histograms, the bars are going to touch each other. So you see that down here in a bar graph traditionally does not. The bars don't touch each other. So I'm going to draw a histogram and make sure and label your axes. The vertical axis, the one that we usually call the y-axis, is always going to be frequency. The horizontal axis or the x-axis in this problem is going to be stock prices. That will change, depending on what the problem we're given. But in this one, we were given stock prices. All right, now I'm going to make a bar. I'm going to have to do the frequency. The highest frequency is 1, 2, 3, 4. So my first bar is going to go up to, oops, that first one only went up to 3. And I'm going to label that the 70 to 79. The next one's going to go up to 4. That's the 80 to 89. And I've got another one at 4 for 90 to 99. And another one at 4 for 100 to 109. Then down to 2, the smallest one. And then back up to 3. So there is a histogram. Sometimes our histograms will have a certain shape to it. So we've got some of our shapes down here. These are our special types of histograms. So whenever your bars or your rectangles are pretty even, they don't have to be exact, but pretty even, we call that uniform. Just like if you had to wear a uniform to school, everybody would dress pretty similar, so everything would be uniform. This next one has several different names. For our textbook, we're going to call it symmetric. And symmetric means it's the same on the left and the right. So if you think about putting a line down the middle here, it'd be very, very similar on the left and right. You can think about symmetry maybe a long time ago when you were like 4 or 5 and you were at preschool or kindergarten. You might have put paint in the middle of a page and then switched it over. When you open it up, you can make like a butterfly or a flower. That was symmetry, the same on the left and the right. These next two guys are my favorite, just because their names make a lot of sense to me. In statistics, we have something called a tail, just like a tail of a dog. And these guys have tails. And wherever the tail is how we name this. So the tail of this one is on the left, so we call this one skew left. And I remember it by thinking about a little monster. His tail is on the left on my little picture, so it's skewed left. And then the opposite of that would be if I had my little blob monster and his tail was on the right, I would call that skewed right. Now, what is really happening with these skewed is you have one data point, or maybe a couple data points that are much lower in the left case or much higher in the right case than the rest of the data. So you can see these little guys down here are skewing it so that it's not symmetrical. And then this last one I have here is called bimodal, because you can see we have these two peaks right here. So it's like where we have a high point, it dips down, and then we have another high point. We call that bimodal.